Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. This is your next lecture of permutations and combinations, where we will primarily focus on studying these 21 points, important results. Okay, these are the 21 points. Most of them we will be discussing in this video, and for that, we will need to know two new topics that are permutations of words, and second one is permutations of digits. Okay, so permutations of words at first we'll study. See, how many permutations of the word computer are there? If this question is there, then you have to understand that it is asking in how many ways can the letters of the word computer be arranged. Okay, 8 letters are there, 8 letters, 8 places, 8 factorial, that's the answer. But if the word is changed and the word is rearranged, in how many ways can the letters of the word computer be rearranged? Then it will be 8 factorial minus 1, because one arrangement is this word itself. Okay, so you know that for n letter word, n factorial is the number of arrangements and n factorial minus 1 is the number of rearrangements. So what about depot? It is 5 letter word, so 5 factorial. Okay, and failure, 7 letter word, so 7 factorial. We will talk about rearrangements only when it is mentioned, otherwise not. Okay, now what about apple? See, p is repeated, so the answer will not be 5 factorial, you know that. But what will be the answer? And what will be the answer if the word is system, if the word is commerce, if the word is anaconda, if the word is independence, if the word is Mississippi? So 5 letters are there, 5 factorial by 2 times p is there, so 2 factorial. 6 letters are there, so 6 factorial by s is written twice, so 2 factorial. 1, 2, 3, 4, 5, 6, 7, 8 letters divided by c is coming twice, 2 factorial. E is coming twice, again 2 factorial. M is coming twice, again 2 factorial. Okay, anaconda, 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial by A is coming thrice, 3 factorial, into N is coming twice, 2 factorial. Independence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letters by E is coming 4 times, 4 factorial. Okay, D is coming twice, 2 factorial, and N is coming thrice, so 3 factorial. Mississippi, 11 factorial by S is coming 4 times, 4 factorial. I is coming 4 times, 4 factorial. P is coming twice, 2 factorial. Okay, so this is how we do permutations of words, and this doesn't only apply in this scenario but also in all other cases which are similar. For example, there are 5 blue balls, 5 blue identical balls, six green identical balls and seven red identical balls. In how many ways can these be arranged in a row? So blue, 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 five, six green balls, seven red balls. In how many ways can these be arranged? So these are total 18. 18 factorial by 5 factorial, 6 factorial, 7 factorial. That's it. Just like the permutations of words. So this topic is not only the permutations of words. In this topic you learn how to do permutations. Okay. Now permutations of digits. This is a completely different topic and I am writing a few questions here. Yeah, these are the questions. How many four-digit numbers are there? So this question you might be already familiar with. You answered this question in your childhood. That largest four-digit number is 999 and 9, and then largest three-digit number is 9 and 9. So subtracting, you got 9,000. Okay, so 9,000 was your answer. But in this chapter, the same question will be answered in a different way. Yes, the answer will be the same, but the approach will be different. And you have to keep one thing in mind: whatever number you are making, if a four-digit number is there, then the first digit from the left, that means this digit, can never be zero. If this digit is zero, say 0469, then this is not a four-digit number, but it is a three-digit number because it is not actually 0469, it is only 469. So it is a three-digit number. So this number will not be counted when you are counting four-digit numbers. So you have to keep in mind, you have to avoid putting zero here. Okay. Now, how many four-digit numbers are there? So if restrictions are not there about repetition or no repetition, then we are free to repeat all digits. That means at the first place we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 options. I'm not filling 9 here right now. Okay. I'm not filling 9 here. This 9 represents the number of options I have. Okay. This is not the digit 9 filled. Maybe here I put say 3 or let's say 2. But there are 9 options at the first place. Okay. Then at the second place I can also put 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 options. Then again 10 options at this place, also 10 options at this place. Total 9,000. Okay. All places to be filled. The case of or and the case of and every time. And so multiply and hence 9,000. How many four-digit numbers are there with no digit repeated? See how this question is done. You have to be very careful. 1, 2, 3, 4. At the first place, you have options 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, never start from this side because restriction is at this place. So you have to start from the side on which you have a restriction. So restriction is on this side, so we always start from this side because there is a restriction that we cannot put 0 here at the first place. So that is a restriction. That restriction is not anywhere else. Okay, so 9 options we have here. Say I put here 4. So 4 is gone. Now there are 1, 2, 3, 5, 6, 7, 8, 9. But 0 can also be put. So again 9 options. Say I have put 7 here. Now the options left are, because no repetition allowed, so 4 is used, 4 will not be used. 7 is used, 4, 7 will not be used. I'm just giving you an example to count the number of possibilities. Now I have 8 options left. Okay. Then say 5 is used here, then I will be having 7 options. So why did you repeat 9 when repetition is not allowed? That's what I'm telling you from the very beginning. You have to be very careful while watching this video, while understanding this topic, that this is not the digit 9, my friend. I just put 4 here. See, I didn't put 9. 9 is the number of options I'm having. 9 is not the digit I'm putting. Okay, so repetition is not there. See, here is 4, here is 7, here is 5. Where there is repetition? There is no repetition. Okay, so that you have to understand very carefully, that the no repetition case is dealt in this manner. 9 into 9 into 8 into 7 is the answer. Okay, so the answer is 4536. 4536. How many 4-digit even numbers are there? See, again, the repetition clause is not given, so we can repeat easily. Even for even number, the last digits should be 0 or 2, 4 or 2 or 4 or 6 or 8. Okay, so 5 options, 10 options here, 10 options here, and 9 options here. Why? Because 0 cannot be used. So this is 4500. 4500. Okay, there are 9000 4-digit numbers are there, out of which 4500 are even and 4500 are odd. Okay, now how many 4-digit numbers are there with all digits odd and no repetition allowed? Okay, this question is a lot easier. All digits odd: 1, 3, 5, 7, 9. If 0 is not there, then there is no restriction here. We can start from either side, and 5 digits to be filled at 4 places we can do in this way, 5p4, or we can do this way also, 5 into 4 into 3 into 2, because at the first place 5 options are there. Say 7 is gone, then 4 options will be left. So 3 is also gone, then 3 options will be left. And this way 5 into 4 into 3 into 2, anyway you are getting 120 as answer. In this way also 5 factorial by 5 minus 4, that is 1 factorial. So 120 by 1, that is 120. 120 is the correct answer for this. Okay. All digits odd and no repetition. All even digits. All even digits means 1, 2, 3, 4. Here you can use all 5 digits. Here you can use all 5 digits. Here also you can use all 5 digits. But here you can use only 2 or 4 or 6 or 8. All even digits, but 0 is not allowed at the first place. So 4 options are here. Okay. So 4 into 5 into 5 into 5, that is 125 into 4, that is 500. 500 numbers will be there. The last question: how many 4-digit numbers are there with all even digits and no repetition allowed? How many 4-digit numbers are there with all even digits and no repetition allowed? Okay. So at the first place there are 4 options: 2 or 4 or 6 or 8. Say 8 is gone, then 2 or 4 or 6, but 0 is also allowed. So again 4 options. Now 3 and then 2. Okay. So 96 is the correct answer. Now there is a question. Now there is a question for you as a homework. How many 4-digit even numbers are there if repetition is not allowed? What is the complexity I am telling you? 4-digit even numbers, that doesn't mean all digits even. Here you can use 1, 3, 5, 7, 9 also. Only at this place you have restriction 0 or 2 or 4 or 6 or 8. And at this place no 0. So this way and this way, both ways you have restrictions, and you have to solve this question. Uh, so I am giving this question to you as a homework. In the next video, I will be discussing this question. Okay. Now let us move to those uh, points these are the points. The first point being the number of permutations of n different things taken all at a time n factorial. We already studied this in the very first video. Okay. Uh, the number of permutations of n things out of which p1 are similar, p2 are similar. This we studied just a few minutes ago in the same video when we studied permutations of words. Okay. The words like Mississippi, Anaconda, etc. See the number of words formed with the letters of the word Allahabad. So 1, 2, 3, 4, 5, 6, 7, 8, 9 letters are there. Okay, and then A is coming 4 times and L is twice. So 9 factorial by 4 factorial, 2 factorial. Okay. Now the number of permutation and things and different things taken are at a time. Repetition is allowed. And different things are at a time. Repetition is allowed. Let us say there are 3 places to be filled and 5 people are there. So uh, for every place we have 5 options. No, in case of people it will not be applicable because repetition. It is a case of reverse. Say 5 digits are given or 5 objects or 5 letters are given. 5 letters are given and 3 places are there and repetition is allowed. So for every place we have 5 options. So 5 into 5 into 5. So 5 raised to the power 3. Okay. If repetition was not allowed, then it would be 5p3. If repetition was not allowed, it would be 5p3. And if repetition is allowed, then it is 5 raised to the power 3. Now let us come to the illustration. In how many ways can 4 rings be worn in the index ring and 3 fingers? Index ring and middle finger, that means 3 fingers. No restriction of number. Okay, no restriction. That means for the first uh, ring, I have 3 fingers. Okay. For the second ring, also I have 3 fingers. For the third ring, I have 3 fingers, and for the fourth ring, I have 3 fingers. So 3 raised to the power 4. Some students do mistake. They do like this. For the first finger, I have 4 rings. For the second finger, why second finger? And still you can place another ring in first finger also. So this way it will not work. Okay, so 4 into 4 into 4 will not work. That's why 3 into 3 into 3 into 3. Okay, so 3 power 4. Number of selection of r things out of an identical thing. If things are identical, then there cannot be different selections. So only one way. Okay, out of k identical things, if I have to select 0 or more things, if I have to select 1 or more things out of k things, then I have k ways. For one thing there is one way, for 2 things there is one way, for 3 things there is one way. In this way I have k ways, but for 0 thing also I have one another way, hence k plus 1. Okay, total number of selections of 0 or more things out of different things, it is 2 raised to the power n. But for 1 or more things, it will be 1 less, 2 raised to the power n minus 1. For example, I have 6 friends and I have to invite 1 or more of them. I have 6 friends and I have to invite 1 or more of them to my birthday party. That means I can invite 1 of them or 2 of them or 3 or 4 or 5 or all 6. So how many ways I have to invite them? I have 2 raised to the power 6 minus 1, that is 64 minus 1, that means 63 ways. Okay. Now, the number of ways of distributing an identical things among r persons when each person may get any number of things. For example, I have 15 marbles and I have to distribute among 4 kids. So 15 plus 4, 19 minus 1, that will be 18. C, 4 minus 1, that will be 3. So to distribute 15 marbles among 4 kids, this number of ways are there where 0 case is also included. Okay, that one child is getting 0 and remaining 2 children are getting the remaining marbles, or let's say 2 children are getting nothing and the third child is getting all 18 marbles. Sorry, and the remaining two are getting marbles from among the given 18 marbles. There are 4 children. Okay, 4 children are there, and 15 marbles are there. Okay, sorry, 15 marbles are there. I am repeating this entire thing. Extremely sorry for confusion. 15 15 marbles are there and 4 children are there. 15 marbles are there and 4 children are there. So n is 15, r is 4. So it will be 18c3. 18c3 also includes zero case. I am explaining zero case. The kids are A, B, C, and D. Marbles are 15. That means let's say B is getting 0 and the remaining 3 kids are getting the marbles out of 15. No problem. Uh, or let's say B and C both are 0 and A and D are getting the marbles. These cases are also included. That means there is no restriction that every child will get at least one marble. There is no restriction like this in this formula. That I mean to say. Okay. 27 marbles have to be distributed among 4 people. That means 31 minus 30 C3. Okay. The number of ways of divide n non-distinct things, that means identical things, n identical things to r distinct groups. Say I have 15 identical marbles and I have 4 groups, and I will divide 4 non-empty groups. That means in this case I cannot give 0 marble to any group. I have to give at least 1. So I have to distribute 15 marbles in 4 groups. Then the formula will be 14C3. Okay, where non-empty groups only are allowed. Now the number of ways in which n distinct things can be distributed to our different persons. Say 15 different objects I have and there are 4 different people, then the answer will not be 14C3, then it will be 4 raised to the power 15. Okay. Now if I have to divide 9 things in 2 groups of 4 and 5, so 9 factorial by 4 factorial, 5 factorial will be there. Ignore this formula will confuse you. 9 factorial by 4 factorial, 5 factorial. If I have to divide 9 things in 2, 3 and 4, then it will be 9 factorial by 2 factorial, 3 factorial, 4 factorial. Okay. But if I have to divide 8 things in 4 and 4, then 4 and 4 is equal, then it will not be like this. There will be an extra 2 factorial because these are twice. Okay. For example, I have to divide 12 things in 3, 4, 4 and 4. So 4 factorial, 4 factorial, 4 factorial. This comes thrice, so 3 factorial. Okay. Now these formula ncx is equal to ncy. Say 8c3 is equal to 8c5. That means 3 plus 5 is equal to 8. Okay. 9c2 is equal to 9c7. 9c2 equal to 9c2. There is one option. Yes, obviously these are same because 2 and 2 are equal. Otherwise 2 plus 7 must be equal to 9. So either x equal to y or x plus y equal to n. And the formula number 13 is also the same case. These formula we will learn in the due course of the chapter while solving problems. Okay. And you already have the PDF. You try to learn these formula and you try to solve a few questions of the chapter. Okay. You try to solve a few questions of the chapter, and we will be discussing the entire remaining chapter in the next lecture, including circular permutations, and after that we will be doing problem solving lectures. Okay. So if there is any problem in this video, report to me at 8294600829. And sorry for that, I fumbled here in the point number 7. I later explained it again. If there are still any problems, report to me at this number on WhatsApp only. Okay. Don't call on this number. I don't take calls. Thank you so much for watching. Don't forget to like, share and subscribe. Happy learning. Bye bye.